okay, you are given a switch, okay, that is connected to pin B0 and a LED. Okay, so please make a correction here to add a LED to PB7. Okay, you are going to write a program to get the status of the switch and display it at the LED. Okay, whenever the switch is pressed, then what happens here, the LED will turn off. Okay, so based on this figure here, so this is your switch and this is your LED. Okay, so by looking at this switch here, so this switch here is a normally high switch, which is, you see, when you not press the switch, it will give you input 1 to your micro P. But, okay, when you press this switch here is here, what happens is the value that will go to your micro P will, okay, so the micro P will get 0 whenever you press your switch. So this switch here, we call it as a high. Okay, this switch here, we call it as a uh, normally high switch, or sometimes we call it as a what we call here. Okay, I just forgot what we call. Okay, later I will tell you what the switch is. Okay, and then okay, so this, you see this switch here is connected to P0, and this another part here of the PB7 is connected to your LED. Okay, by looking at this LED, okay, you see here the negative terminal go to the ground, while positive is connected to your micro P. So you know that this LED is a common cathode or common anode switch. By looking at this circuit here, is it a common anode or common cathode? Anyone? Okay, so this is a common cathode switch, which is for the common cathode, okay, to turn on the LED, so you need to give 1 to your micro P, and if you're going to turn off this LED, then you need to give 0, okay, from your micro P. Okay, so now what you're going to do here is you're going to write a C programming. So how to write a C programming depending on, okay, first thing first, what you're going to do here is you need to include this file. Okay, so hashtag include avr/io.h. Okay, so this is the thing that you, this is the first thing that you need to do, which is you need to include the io.h file to your program. Okay, then after that, okay, you start with your main program. So int main void followed by open curly bracket and close curly bracket down here. So inside of this main program, okay, you will write down the the first thing here that you're going to write down here is to initialize the input output port. And after you initialize the all input output port, then after that we're going to do the programming for this switches. Okay, the monitoring of these switches. Okay, if you press the switch, then what happen? LED off. If you not press the switch, then the LED always on. Okay, so first, okay, so this is your main program. Okay, then we are going to initialize the input output port. Okay, since this one here we are going to use the port B. Okay, so bear in mind that this port B here has two have an input and output at the same time. So what you're going to do here, you need to select the input and output port very carefully lah. Okay, so how to initialize the input output? Okay, to initialize the input output, you can use the DDRB register. Okay, since this one here we're going to use the port B, so that's why we use the DDRB. Then you need to initialize, okay, the input and output port according to this question. Okay, so in this question here, PB0 will be your input, while PB7 is connected to your LED. So of course lah, this is become your output port. So how to do that? Okay, so you just simply write DDRP equal to 0B1. Okay, so make sure that bit 7 here is 1 because you're going to make it as an output port, and then 1 1 1 1 1 followed by 0. Okay, so this is the two important parts lah. Okay, the first one is on bit 7, which is you need to put 1, while bit 0, okay, so this is your bit 0, you need to put 0. Why? Because you're going to make it as a input port. What about the rest of the bits? Okay, the rest of the bit you can either set it as an input or set it as a output. Okay, but usually we will set it as a output. Okay, so that's why I put DDRB equal to 0B11111110. Okay, the only port B pin 0 is initialized as an input port, while the rest of the port initialized as a output port. Okay, so this is how you're going to write the to initialize the input output at PB7 and PB0. Okay, so if you're not going to write something like this, coding something like this, or you're going to write a fancy way to initialize the input output port, so you can use this second line here. Okay, so this second line here is actually similar to what we'll write in the first line, which is you're going to initialize port B as an output and port B0 as an input. So you see here, DDRB equal to shift 1 to your DDRB7, which is you put 1 to your DDRB7 to your PB7. So now I put here your PB7 got 0, so you already initialize it as output port, and okay, tilde, so this is an inverting, okay, invert 1 at DDRB0 means that you put 0 to your DDRB0 so that your PB0 become input port. So this is another way lah, okay, which is a fancy way to write, to initialize PB0 as an input and PB7 as an output. Okay, so you can write the first line here or second line here. Okay, both are correct. Okay, but normally, okay, I advise you to use this thing lah. Okay, because this is a very easy to you to refer or to refer to this what we call here figure here, to this circuit. Okay, then after you finish initialize the output port, then what happens here is you need to monitor your switches. Okay, so you're going to write a program which is you're going to monitor a switch, okay, to get the status of the switch and display it at a LED. Okay, you're going to monitor the status of switch. Okay, to monitor status of switch, you need to monitor it forever. So that's why I put a while loop here, while 1, okay, which is you're going to monitor your switch forever. Okay, continuously. Okay, so next what you're going to do? Okay, so you need to have a if else statement. Okay, you're going to check whether this switch is pressed or not by using the if else statement. Okay, so this one here. Let's look what happened when the switch is pressed. Okay, if pin B equal to, okay, before that, okay, before we start with our while loop, okay, there is another what we call here, another code or another instruction that I missed here, okay, which is since this is an input connected to your switch, so you need to enable your pull up resistor. So how to enable your pull up resistor? By put 1 to your port B. So port B equal to 0B0000000001. Okay, so here this is the location that you need to put 1, which is at your switches. Which switcher is located at PB0, so that's why only PB0 get while the rest you put 0 because you're going to enable your pull up resistor. Okay, then after that you start with your while loop. Okay, so while one, if pin B equal to, okay, now you're going to check whether this one here is pressed or not. Okay, when pressed, what happen? When pressed, PB0 will retrieve or will read 0 from your switch. This is when you press. Okay, so this one we call it as an active low switch. Okay, why active low switch? Because every time you press the switch, okay, the output 0 will go to your micro P. So that's why we call it as an active low switch. This is the term that I forget earlier, okay, which is active low switch. Switches, you have two types. One active low, the other one is active high. Active high, whenever you press the switch, it will produce output 1, while active low, whenever you press the switch, it will produce output 0. Okay, so since this one here, okay, every time you press the switch, okay, the micro P here will get the value from this ground, okay, which is a produce 0. So what you going, okay, so what is the value that you're going to read in your pin B is if pin B equal to 0B1110, okay, which is here. You see this one. Okay, because you're going to
Question.
see the
Also,
PB0 either it is pressed or not. If it produce output 0, so that is when the switch is pressed. So what happens when the switch is pressed? Okay, when the switch is pressed, LED will turn off. Okay, so the LED at PB7 will turn off. So what value that you're going to send to PB7 so that the LED turn off? Okay, you need to send 0 because this is a 0. So you have a 0 and 0 here. There is no current flow through your LED. So your LED will turn off. So that's why I put port B equal to 0. Okay. But actually, this one here, okay, you can change it, okay, to port B equal to 0B000000001. Why 1? Because if you put 0 here, what happen here? The pull-up resistor at PB0 will be disabled. We don't want to do that. So why not we just simply write port B equal to 0B00001. Okay, so make sure that, okay, the important bit here is PB0 and PB7. Okay, so PB7 you give 0, while PB0 you still enable the pull-up resistor. Okay, so this is what happens when the switch is pressed. Okay, what happens when the switch is not pressed? Okay, if the switch is released, and when the switch is released, what value that will go to your PB0? It will give you 1. So else port B equal to, okay, so please replace this one here to 0B10000001. Why? Because I don't want to disable the pull-up resistor at PB0. Okay, if you put something like this, then what happen here? The pull-up resistor at PB0 already been disabled. Okay, so that's why 0B equal. Okay, now the LED at PB1 is turned on because I give 1 to PB7. Okay, so this is the how to write the program, okay, in order to monitor this active low switch and give the what we call it, okay, and depending on this switch here, and it will produce output on your LEDs. Okay, any question up until here?
so
Yeah.
I have a question I want to ask. If pin B is equal to 0B 1 1 1 1 1 0, right?
Yeah,
The fun Y is 1 1 1 1 because
yeah.
just now you said already the PB1 to PB7 is the output. Then how can the others pin there will be 1? Should be 0, right?
Okay, so this part here, okay. So actually, this part to make it one, okay, you can simply, okay, that is a good suggestion because we already make it as a what we call here output at the from port B7 to port B1. Okay, so how we going to make sure that this value is 1? Okay, because we already made it as output. So by right, the pin B is 0. Okay, because we not going to have the switches are connected to this bits here. So how to do that? Okay, okay, to make this one here become 1, okay, equal to 1. So what you're going to do here is, okay, we can put a mask at pin B. Okay, so how to put a mask? Okay, so we simply write pin B equal to, you can put here, okay, before the while loop, okay, pin B equal to 0B. Okay, so we can put something like this. Or if you don't want to put this mask here, okay, the other thing that you can do here is, okay, you can change this one, okay, to pin B equal to pin B, and then end with 0B 1 1 1 1 1 1 0. Okay, so what happened here? So this one here, okay, is will check whether this value is 0 or not. Okay, so what happened here is, okay, no matter what is your pin B value, okay, if your pin B value is something like, okay, wait, is it okay if I put here and with 0? Because if I and with, wait, yeah, pin B sama dengan, I put 1 here, what happens if I put 1 and then it become, let's say your pin B is currently 0 0 0 0 0 and 0 0 0 1. If I put this thing here, and it will produce, okay, I cannot do that. It produce 0. So if produce 0, then what happen here? You cannot go to this part. Okay, so what you going to do? Okay, wait, yeah. We better put the masking, okay, at the beginning here. Okay, which is this is the initial value, which is pin B equal to 0 B 1 1 1 1 1 1. So this is the default, okay, which is every time you not press the switch, what happen here is this value here will always 1, and the rest of the pin also get 1. So this is the masking part. Okay, so when you press the switch, okay, it will produce 0 at this part. So when what happen here is when pin B equal to this value, then you will give port B equal to 0. So else the port B equal to this value here. Okay. So you need to put a mask before the while loop. Okay. So that this four, what we call here, this 4 bit here, sorry, this 7 bits here, okay, is set at 1. Okay. Any question up until here? Any other question? Thank you, go.
No, doctor.
Okay, if no question, then we go to another examples. Okay, so this is a next examples. Okay, which is, okay, I make this bigger. Can I make this one bigger? Can I? Okay, never mind. Okay, by using the 7-segment display, okay, you're going to write a program to display number 0 to 9 continuously. Okay, which is you're going to display. Okay, so you have a 7-segment display. Okay, so I just draw the circuit. So this is your Atmega 32. Okay, and then you have a 7-segment display connected to your, this is a bit connected to your Atmega 32. And what happened here is this 7-segment display will display a counting from 0 to 9 continuously. Okay, so let's this one here, this 7-segment display is connected to port B. Okay, so this is a port B, and the type of 7-segment common configuration of 7-segment display used is common caten. Okay, so now we're going to find out how to do the program so that it will count from 0 to 9 continuously. Okay, so this is the yellow background here. So this one here, this is in what we call here, this is in assembly language. Okay, we're not going to look at the assembly language. We are going to focusing on the C programming part. So how to do that? Okay, so in these examples, okay, since you're going to do a counting sequence from 0 to 9 and going to display it on the 7-segment display, so we need to create a certain delay in order to do the counting sequence. Why? Because if you not put a delay between counting 0 to 9, what happens? You cannot see this 7-segment display change from 0 to 1, 2, 3, 4 until 9, because it's very fast. You cannot see the counting sequence. So what we need to do, we need to put a certain delay to that. Okay, so how to do that? Okay, first, okay, again, okay, we are going to include this file. Okay, hashtag include avr/io.h. Okay, after you include this file here, okay, we are going to create a delay, okay, between 0, 1, 2, 3, 4, 5, 6 until 9, so that we can see the counting on this 7-segment display. Okay, to create the delay, there are 3 types to create a delay. One, by using the for loops. The second one, by using the the delay library that are available in the C programs. And the third one, by using the timer programming. Okay, so in this case here, we are going to use the timer library. Okay, a delay library that is available in the C program. Okay, so that's why we include this file here. Okay, include util/delay.h, because we're going to use the delay function. They are available in C language. Okay, and then before that, okay, you're going to define your CPU. Okay, because to use a delay function, you need to define your speed of the CPU. Okay, so in this case, we're going to use the 1 megahertz CPU. So that's why we define F underscore CPU 1 million. Okay, 1 million is stand for 1 megahertz. Okay, after you include all this header or all these files here, then we start with our main program. Okay, int main void, and then we initialize the input output point. Okay, that is the first thing that you're going to do. Okay, initialize your input output point. Okay, since this 7 segment is connected to port B, so we need to initialize port B so that our port B become output point. So how to initialize port B become output point? By put FF, okay, put 1 to your DDR-B. So that's why DDR-B equal to OXFF, which is you initialize your port B, the whole port B, okay, the whole bit of your port B as a output point. And then after that, we do the counting sequence, okay, to count from 0 to 9. Okay, there are two ways to do that. Okay, one, by using a loops. Okay, satu kita boleh guna loops. Okay, a second one here, you can simply send the value. Okay, okay, send the code, the value that you're going to display to your what we call here 7 segment display one by one. Okay, so in this example, we're going to look at this number 2 lah. Okay, send line by line. Okay, one by one, the sequence one by one. Okay, so since this one here we're going to do it continuously, okay, the counting will be count continuously. So what you're going to do here is you need to do the while loop. Okay, while one, open curly bracket and close curly bracket. So this is the what we call here the simple way to do the counting, which is you send the value to be displayed on 7 segment display one by one. Okay, so first we're going to display number 0. Okay, so according to what we call here 7 segment. Okay, so you have A, B, C, D, E, F, G, and H. Okay, so this A, B, C, D, E, F, G, and H. Okay, so according to 7 segment display, okay, to display number 0, okay, you need to turn on at LED A, B, C, D, E, and F. Okay, so this since this is a common cat, so to turn on we need to give 1 lah dekat sini. Okay, you need to give 1 at A, B, C, D, E, F, while G and H got 0. So that's why the first value here is 3F. This is to display 0. Okay, to display 1, so what will be the value here? B and C will be turned on. Okay, to display 1, B and C will turn on while the rest will turn off. Okay, so what will be the code here that you're going to set out in order to display 1, which is 0, 6. Okay, and then followed by 2. Okay, 2 is A, B, G, and this one. Okay, so A, B, C turn off, D, E, F turn off, G turn on, and this one is turn off. Okay, so next, what will be the value that you're going to send out? So this one here is 8 by using the 8 4 to 1 methods. This is 4, 5. Okay, so this is a 5, and this is 8, 9, 10, 11, 11 is B. Okay, 5B, and you do it until 9. Okay, which is to display 9. Okay, so this is your number 9, A, B, C, D, E, F, G. Okay, so A, B, C, D turn off, E also turn off, F on, G on, and this. So this is the value here, which is 6. Okay, 6, 7. Okay, while this one is 6F, because this 9 here will have this okay, the D is turned on. Okay, so you have two time here. One, you either you're going to display something like this, or you can display something like this. Okay, so after you get all the codes here, what you're going to do is you set out this code here one by one. Okay, so port B. So first you display 0, port B equal to OX3F, and then call the delay. So this is how you're going to use the delay function, underscore delay underscore MS followed by a certain value. Okay, because this one here we're going to we're going to make a delay of 2 milliseconds. So that's why we put 2000 here. Okay, because the CPU speed is 1 megahertz. So we put 2000 in order to make a delay of 2 milliseconds. Okay, so this is to display 0. And then to display 1, okay, you send out this value to port B. Port B equal to OX06. Okay, this value here to port B and call the delay. Okay, and then you send to, which is port B equal to this value 5B and call the delay. Is number 3, 4, 5, 6, 7, 8, and 9. Okay, port B equal to OX6F or OX67 and call the delay. Okay, and then you do it forever. Okay. So this is by using the second method lah, okay, which is you send one by one. This is the easy way to send the counting from 0 to 9 to your 7-segment delay. Okay, next we're going to see another what we call here example here. Okay, you're going to write an AVRC program, okay, to get a byte of data from port B and then send it to your port C. So we draw the ATmega32. Okay, so what happened here? Okay, you have a port B and port C. Okay, get a data, a byte of data, which is 8-bit data. Okay, so this is your port B. Okay, this port B here, you connected to switch lah. Okay, so this is your switch. This is an 8-bit. Okay, all 8-bit port B is connected to the switches. Okay, and then whatever the value that read from the port B will send to your port C. So port C, since it is sent, so you know that, so this one here, okay, you can connect it to the LEDs. Okay, so this is also 8-bit lah. Okay, 8-bit and this is 8-bit. Okay, so how to write a program? Okay, so what you're going to do first, include the avr/io.h file. Okay, and then after that, do you need to include the delay function? No need, because you're only going to send whatever you read from these switches, and then you send it to your LED. Okay, no need to create a delay. Okay, so and then start with your main program. Okay, int main void. Okay, so what you're going to do first? Okay, initialize your input output. Okay, since you have two port here, port B and port C. Okay, so you need to initialize both port lah. Okay, port C become an output port, so DDRC equal to OX FF. So port C become output port. What about your port B? Okay, DDRC, B equal to 0. You make your port B as a input port. Okay, since this port B is connected to the switches, so why don't we initialize or enable the pull-up resistor? Okay, so port B equal to OX FF. Okay, after you initialize all the input output port, then what you're going to do? Okay, you're going to write the programs lah. Okay, since this one here, okay, we will do it continuously. Okay, so we can put it inside a while loop. Okay, while 1, open curly bracket, and close curly bracket. Okay, so now, okay, you can simply write something like this. Okay, port C equal to pin B. Okay, whatever whatever the value received from the pin B will go to your port C. Okay, you can simply write something like this, or you can use the variable. Okay, which is you create a variable. In this case here, this variable we call it as a temp. Okay, to store a data temporarily. So since you use a variable here, so what you're going to do is you need to initialize this variable. What is the data type of this variable? Okay, since this is an 8-bit data, okay, and it's an unsigned, so why not we use the unsigned char temp? Okay, so you know that this is an 8-bit data with an unsigned number. So first, temp equal to pin B. So the temp will have whatever value that coming from the switches here will put to your temp. And then after that, you send this value to your port C by writing port C equal to temp. Okay. So this is how you're going to send a data from this switch to your LED. Any question up until here? Okay, if no question, then we go. Yeah.
In the test, are we going to do it in C language or assembly?
C language. We're not doing in assembly. Okay, now we are in the C programming.
Okay.
Okay, for the input outputs onwards, we are going to write in the C programming.
Thank you.
Okay, then we have another example. Okay, write an AVR C code to monitor bit 7 on port B. If it is 1, make pin 4 of port B as an input, else change pin 4 port B as a output. Okay, so what you're going to do? Okay, we draw the circuit here. Okay, so you have a PB7. Okay, so first is a port B7. Okay, so this is a PB7. Okay, and then connected to your switch. Why I connect to switch? Okay, why? Because you're going to monitor. Okay, every time you're going to monitor, so you need to monitor it by using a switch, which is it is connected to your. Okay, make sure that this become your input port. Okay, so if PB7 equal to 1, so what happens? Make bit for port B as input. Okay, so you have a PB4 here. Okay, so when PB7 equal to 1, okay, so you need to make this one as a input port. If 0, then make it as a output port. Okay, so how to write the program? Okay, so since we already draw the circuits and know what the question want, so we started with the including the AVR/IO file. So this is the thing that you're going to do. Okay, AVR/IO.h, and then after that you start with your main program. Okay, and then goes to the bracket down here. Okay, next. After that, okay, you're going to initialize your port B7 as a input port. Okay, so how to do that? Okay, so DDRB equal to, okay, DDRB and with this value. Okay, so what happened here? So this port B, okay, so this one here, actually you inverted this one at bit 7, which is you shift it to the bit 7, okay, and end with your DDRB. Okay, only bit 7 will change while the other of the bit will not change. Okay, so this is DDRB equal to DDRB. Okay, so PB7 equal to input port. So you make it as a input port. Okay, while the rest, okay, the rest will uh, follow the previous value of your DDRB. Okay, the default value of your DDRB. And then what happened next? Okay, since this one here you connected to the switch, okay, so it advised to enable the pull up resistor at PB7. Okay, so 0B1 0 0 0 0 0 0 0. Okay, so PB7 enable pull up resistor. Okay, next, after that, what are you going to do? Okay, then we're going to monitor this PV7. Okay, how to monitor PV7? Okay, so we're going to monitor it continuously. Okay, so if, okay, so pin B7, sorry, if pin B and with, okay, so what happened here? Okay, you're going to check whether the pin B7 you end with this value is true or not. Okay, so this is, you're going to check whether this value is pressed or not. Okay, if pressed, so what happened? It will give you value 1. If not pressed, it will give you value 0. Okay, so if pin B end with this value, okay, so actually this one now, shift 1 to the left 7 times. So this is the value that you're going to end with pin B. Okay, so pin B end with this value. 1 0 0 0 0 0. Okay, is it true or not? If this value here is true, then what happen? Okay, if the pin B is pressed and this is a true, okay, so what happened here? DDRB equal to DDRB and with, okay, if 1, so what happen? You need to make your PB4 as a input port. Okay, so that's why. Okay, something like this. Or you can simply write down DDRB equal to, okay, make sure that this one you make, okay, port B, pin number 4, you make it as an input port, and at the same time, port B, pin 7 remain input port. Okay, so this is the value lah. Okay, 0, this is PB7, 7, 6, 5, 4. This one also 0. Okay, and then what about the rest? 3, 2, 1, 0. Okay, you can either put it 0 or you can put it 1. Okay, as long as I can see this one is 0 and this one also 0, then you will give. Okay, then your answer will correct lah. Okay, I'm only focusing on the PB port B4 and port B7. Okay, so what about this line here? Okay, this line actually, okay, you're going to end whatever value from here, okay, which is the started value that we put here is this value, correct? Okay, 0 and end with the DDRB. So, and then we end again with this value. So only this value will change while the other bit remains. Okay. Okay, so this is what happened on this line. Okay, only one bit at port PB4 is changed while the rest is remain. Okay, and then after we after we initialize the PB4 as an input port, then what you're going to do? Okay, you need to use the else statement. Okay, when the PB7 equal to 0, so what happens? You need to make sure that PB4 equal to output. Okay, so you can use the DDRB equal to DDRB or with, okay, put 1 to your port B. Ataupun, or you can simply write DDRB equal to 0. Okay, make sure this PB7 is remain 0 lah, because this is you connected to your switch, and 1, 1, 1, 1, 1, 1, 1. Okay, here. Okay, make sure that PB4 is input. Initialized as a output port. Okay, so this is an input and this is as output port. Okay, then you close your program. Okay, you can use either this line here, okay, this way of coding, or this way of coding in order to initialize the port B pin number 4 as an input or output port. Okay, meanwhile the PB7 port B pin number 7 is the remain as a input port. Okay, any question up until here? If no question, we go to another examples. Okay, we have a lot of examples. Okay, and then this one here, okay, you're going to write a C program, okay, to get the status of bit 5 port B and set it to bit 7 of port C continuously. Okay, so actually this one here is similar what we did in this example. Okay, so this one we read the whole 8 bits data from port B and send them to port C. But in this case here, okay, we need to have a 1 bit data from port B and set it to port C. Okay, so this something like this lah. Okay, you draw your circuit. Okay, you have a PB5. Okay, get the status of PB5, so you know that this is connected to your switches. And then you have a PC7, so this is your PC7, and send it to P7 continuously. Okay, so you know that this one is connected to LEDs. Okay, so that you can see the status of these switches as either it produce 1 or 0. Okay, so what you're going to do? Okay, again, include this file and started with your main program. Okay, and then initialize your input output port. Okay, so in this case here, only PB5 is initialized as an input, while PC7 is initialized as an output. You can simply write something like this, or you can initialize the whole port B5 as our input also can, and the whole port C as our output also can. Okay, because the rest of the bit is not connected to anything. So why not we just initialize the whole port C as an input and the whole port B as a, the whole port C as an output and the whole port B as a input. Okay, you have two options here. Either you only set one bit as an input or output, ataupun the whole port as an input or output at the same time. Okay, then why one? Okay, because you're going to monitor continuously, so we need to use a while one. If pin B and with this value, okay, which is we need to check lah dekat pin B. If that pin B equal to this value, okay, is true, okay, whatever the value coming from pin B, and we need to end with this value here. Okay, whenever this one is pressed, it will give 1. So what happened here is port C equal to 1. Okay, port C equal to port C, or with put 1 to bit 7, or you can simply change it to port C, okay, to make it easier. Port C equal to 0B, give 1, and the rest you put 0. Okay, as long as PC7 is turned on, then your answer will correct lah. So this is the similar to this writing here. Okay, else port C equal to port C and with inverting 1 at bit 7, ataupun you can change it to port C equal to 0B000000000. Okay, as long as this one get 0, that should be correct lah. Okay, so this is how you're going to check the monitor. Okay, check the status of PB5 and set it to the PC7 continuously. Any question up until here? Okay, if no question, then we go to next slide. Okay, so this is a AVRC time delay. How to generate the time delay in AVRC programming. Okay, as I mentioned earlier, you have 3 ways to generate a time delay. First, by using a for loop. Okay, but by using this for loop here, you will never get the exact delay that you going to generate. Okay, second, by using the SKEE or delay function in SKEE, and the third one by using the timer programming. Okay, only 2 and 3 will give you the exact delay time that you're going to generate. Okay, if you're going to generate 200 milliseconds delay by using 2 and 3, you will get the 200 milliseconds. But if you use the for loop, sometimes the delay that you generate is smaller than 200 milliseconds, or sometimes it will be bigger than 200 milliseconds, which is you not exactly get the exact delay that you're going to generate. Okay, so 3 ways to create time delay in C: by using a simple for loop, predefined C function, and AVR timer. So AVR timer we will learn in the next module, okay, which is a timer programming. And now we are going to see in this by using a simple for loop and predefined C function. Okay, so this is how you're going to generate by using a for loop. Okay, so this is your delay function. Okay, which is you're going to generate a delay 100 milliseconds. Okay, so this is the for loop that you're going to do. Okay, so by using this one here, you will not get the exact delay that you're going to generate. And then you see here, okay, you need to try with different number on your compiler and examine the result. Okay, you need to try with the value here, any value here, so that you will get the close delay that you're going to generate. Okay, so this is by using the for loops. Okay, and then by using a C function. Okay, so to using a C function, what you're going to do here is you need to include this file here. Okay, include util underscore delay h, and you need to define your CPU speed. Okay, so this is the 2 important thing. Okay, first, initialize your CPU speed, and second one, need to include this library here. or this file here. And then after you do this thing here, then after that you can use the underscore delay underscore ms followed by what is the value that you're going to put. Okay, so this value will determine what are your delay. For example, if you're going to generate a 2 millisecond delay, so you could put a 2000 here. If you're going to generate a 1 millisecond delay, so you put 1000 just in it. Okay, so you need to put any numbers inside here. Okay, so this is for to generate a delay by using the delay function. Okay, and then okay, so next is Atmega 32 IO problem. Okay, below are the few problems that are related to Atmega 32 input output port. Okay, the first one here is input output port are scarce. Okay, means that even though you have a 32 input output port, sometimes that 32 input output port are not enough. Okay, so what are you going to do? Is it you're going to buy a new chip that have a bigger number of input output port, or you will still use the same chip but using another modification in order to increase the number of an input and the number of the output. Okay. Then not enough time to buy micro P with more IOs. For example, you buy a Mega 32, okay, and then suddenly, okay, in your project, instead of you need to use a 32 sensors or 32 switches and LEDs, you need to increase that number of input output to 64, for example. Okay, so what are you going to do? Is it you going to buy a new one? Okay, if you're going to buy a new one, but sometimes there is not enough time to buy a new micro P, a new micro P, a new with more input output. So what are you going to do? Okay, so you still need to use the same Atmega 32 IC, but you need to do some modification so that the number of the input output can be expanded. Okay, required model not readily available. Okay, sometimes you have a compatibility issue, especially using as assembly language. Okay, some microprocessor use the different assembly language. Okay, for example, you have two microprocessor A and micro PB. Microprocessor A might use the different assembly language to micro PB. So you cannot simply use the same coding to your micro PB. Or simply no budget, of course lah. If you're going to have the micro P with more IOs, then the price will expensive compared to the micro P with a lower IOs. Okay, so what are the solution? Use the MSI device. Okay, what is a MSI device? Okay, MSI is stand for the medium scale integrated circuit, which is this MSI device can be used in order to expand, okay, to increase the number of input and output on your Atmega 32. I think I will stop here. Okay, so this slide here, I will give you a pre-recorded video so that you can watch it by yourself. Any question up until here? Ada soalan tak before we stop our class?